Hello everyone. Welcome to the world of data mining. Data mining is very popular and one of the fields that are in demand today. Data mining is the process of discovering patterns in large data sets. In simple words, it is a process of mining knowledge from data. Data mining is interdisciplinary field and has wide number of applications including education, healthcare, industries, marketing, finance and many more. This lecture is part of lecture series for the course titled Data Mining and Data Warehousing. This course is offered as one of the electives at 4th year Computer Engineering. I am Professor Varsha Patil, working with Department of Computer Engineering, Matoshri College of Engineering and Research Center situated at Nasik. Institute is NAAC accredited and is well known for its discipline and the best academics. Institute offers 7 UG, 5 PG and 2 PhD programs. Institute is affiliated to Savitribai Phule, Pune University. Popularly known as Oxford of the East, the Savitribai Phule Pune University is A+ NAAC accredited and is ranked 2 among universities in India by World University Rankings Organization in year 2019. Let us learn topics of data mining now. In this lecture, we shall learn about basic statistical description of data. As a highly application-driven domain, data mining has incorporated many techniques from other domains. One of them is statistics. Statistics studies the collection, analysis, interpretation, and presentation of data. Data mining has an inherent connection with the statistics. Let us learn few terms which are related with the data pre-processing and are required for. In earlier lecture, we have learned few topics which were again a revision of few basic concepts and definitions of data object, attributes and attribute types. For data pre-processing to be successful, it is very essential to have an overall picture of our data. Basic statistical description can be used to identify properties of data and highlight which data values should be treated as noisy and outliers. Intuitively speaking, given an attribute, we wish to find out where do most of the values fall. And this is nothing but computing a central tendency. What is central tendency? Let's learn. So we'll be learning in this lecture what is central tendency and what are its typical measures, that is mean, median, mode, range, mid-range, symmetric and skewed data. You have already learned these terms in statistics. We will be revising it with few examples and most importantly, we will be learning what it is, how to compute and their relevance with respect to data mining. One of the key terms from statistics which is borrowed in data mining is central tendency. A measure of central tendency indicates where most of the values in data distribution fall, and it is also referred as central location of distribution. Central tendency is a single value that identifies central position within set of data. In data pre-processing, often it is observed that data is noisy. There are many missing values and there is a lot of inconsistent data in a data which is to be processed. When we pre-process data, we will be replacing those inconsistent data with some new values. We will be filling up the missing values, and for doing this we require to compute a central tendency. How we will be learning soon. The most common measures of central tendency in statistics are mean, median and mode. Each one of these calculates the central point in a different way. The central tendency of a distribution represents one characteristics of a distribution. This characteristics is used to find out at what central location do most of the data lie. And this also helps in finding a variability around this central value. We shall be learning these terms mean, median and mode along with few examples. While working with these examples, we shall deal with the data which is given in one of these formats. This is first, we have 100 students in data where there are 62 students in a class and their test marks out of 100 are listed in this table. Here marks are listed in the form of a range. Students who have scored marks between 0 to 10 are 5. 11 students have scored marks between 11 to 20. 19 students have scored marks between 21 to 30, and similarly 2 students score is lying between 81 to 90, and there are 0 students who have scored more than 91 marks up to 100. Let us look at the other example. Here this is the data for one particular department. These are the employees and this is the salary. Manager has a salary 98,000. Other employees, employee 1 has 79,000, employee 2 67,000, so on. A clerk of that department has a salary 12,000. This is set of employees for particular department and their salary is listed in thousands. Let us look at the third example. In third example, we are given a count of particular words in particular document. Here, these are the words whose frequency count is listed. A word bad has appeared 21 times in that document. Word happy appeared 45 number of times. Similarly, 12 times the word well appeared in the document, and for other words, the word frequency count is listed in a second row. We will be working on few examples which will be one of these kinds. Let's see how to compute a mean. Mean is obtained by adding all the values in a sample set and then dividing it by a sample size. Here let's look at the formula. A mean x bar is computed with taking an addition of all the members of a sample set and dividing it with the size of a sample set. If we represent these members as x1, x2, x3, then this term is representing it as x1 plus x2 like this up to xn divided by n. This is how we compute mean. Let's look at one example. Here we are having 4 members in a set as 21, 22, 48 and 53. Computing its mean is simple. We take summation of all the members, divide it by 4 and we get mean as 36. Let's look at one more example. Let A be a set representing a salary in thousands and we have members as 30,000, 36,000, so on up to 110,000. To compute the mean, we take summation of all these 12 salary and then we divide it by 12 and we come to know that mean salary of these employees, which was varying from 30 to 110,000, is 58,000. This was mean, and let us see what is weighted mean. Sometimes each value in the set is also associated with some weight. We had seen one example in which a document and set of words, and for each word a frequency was associated which indicated that how many times that word occurred in the document. That frequency was nothing but a weight associated with that particular word. These weights reflect the significance, importance or occurrence frequency which is attached with the respective values. This is called as a weighted mean or a weighted average. Mean is also termed as average. So when we take weighted mean, it is represented as a weighted average. And how do we compute weighted average? Is here x bar is equal to, we are going to again take a sum of all samples, but we will be taking the sample value into its weight associated and then we'll divide it with the sum of all weights. Let's look at one example for this. We are given a data where a number of students who scored particular marks are listed. We have few students whose marks are listed in this table. They indicate as the marks 22 has been scored by 2 students. There are 6 students who scored marks 34. There are 7 students who scored marks 58. There are 2 students who scored marks 91, and there is one single student who scored 95 marks. These are the marks listed for the students and the number of times those marks appeared in the score sheet. Let X be a set of all class marks for this 50 students. Now when to compute its weighted average, what we do is we take a sum of this xi and weight. So for each x, that is 2 into 22, 34 into 6 plus 46 into 13, so on up to 95 into 1. We take this weight and x multiplication and we divide it by sum of all the weights. So we get here average, weighted average as 59.88. Here n is 50, which is nothing but set of all students. We just computed mean for some example data sets. Mean can be calculated for any numerical data set. Value of mean is unambiguous and it is unique for that particular data set. If we take a data set and if we try to replace each value with a mean, then sum of all those data samples remains same as while computing mean we have taken into account all the values. But mean always is not a best way for measuring a center of a data. When this happens, if data is symmetric, then there is no problem. But if it is a skewed data, then there are some issues associated with. We shall be learning them. A major problem of mean is in data set, if there are some extremes like two lower values or two higher values, then mean does not give a proper central tendency of a data. Let's see how. In statistics, those extreme values are named as outliers. These outliers generally differ from observed values in the set. Outlier may be due to variability in the measurement, or it may indicate the experimental error. It may be some inconsistent record of one particular data, or it is something which is to be excluded. An outlier always need not be excluded until and unless it proves that it can cause some serious problem in your statistical analysis. Let's look at one example to understand this. This is an example where X is set of class test marks for a class of 6 students. Let the marks for 5 students be something as y1 and y2, and let's say marks of one of the students are missing and you are given a task to guess the marks for that 6 student. First set y1 is we are having 22, 37, 39, 48 and 94, and in second set the same values except 94 is replaced with 44. To understand what happens when values are something like 94 as compared to the remaining values. Now if we take a mean for y1 and if we take a mean for y2, then we can notice the difference. For y1 and y2, the mean comes out to be 48.8 and for y2 it is 38. If we see a difference, then difference is between these because of these two values. In y1, for remaining values, like first 4 values remain same and the last one is 94, and in y2 it is 44. 44 is in the range of other numbers comparatively, whereas 94 is much higher than these values. And now if we try to find out its mean, then in y1 it comes out to be 48.8, whereas for y2 it is 38. So if you see, there is a difference of almost 10 marks in the mean. So if we try to replace the 6 students marks, in first case y1 it is going to be 48 and in second case it is going to be 38, which is a difference, noticeable difference of 10 marks. Let's look at one more example. Here we again have a set of 6 students where 5 students marks are from listed in y1 and y2, two sets, and here there is a difference of first mark. It was a higher value which we treated as an outlier. We will see that if once student scores lesser marks, what effect it makes on average. In earlier case, one student marks were higher and it pulled up average. Now here the smaller value will pull down average of this y1 and y2. In y1 the average comes out to be 23, whereas in y2 the average comes out to be 33. So for 6 student, if you are guessing the marks, if you are going to place the marks based on the average of remaining students, then if one student has scored 2 less marks, then average comes out to be, it is pulled down to 23. And in earlier case, if average because of one student who scored 94 marks was pulled up by 10. Here also there is a difference of 10. There also we noticed that there was a difference in two means. Let's see one more example. This is for 10 employees and their salaries, and we will see that how mean is affected because of some higher salaries or the lower salaries. Here the two salaries 94,000 and 140,000 are excluded, and then mean is computed for both the sets, and you will see that there is a huge difference. If this is in dollars, then the average comes out to be $48.66 thousand. If we add these two higher values 94 and 140, and if we exclude those, then average is somewhere around $29.14 thousand. So this shows that if there are some extreme values lying in the set which are called as outliers, then they affect mean, which is very noticeable. So what could be a solution to avoid this, either pulling up or pulling down because of few values in the set that is affecting mean, is taking a trimmed mean. Now what is trimmed mean? In trimmed mean, what we do is we try to exclude those extremes. To offset the effect caused because of this small number of extreme values, we can instead use a trimmed mean. What it will do is, it will obtain by chopping off the values at high and low extremes. When you chop down the values at both the ends, then it shouldn't be too less like 2%, or it shouldn't be too high like 20%. Too less chopping may not give you the expected results, and too high chopping like 20% may be a loss of valuable information. Let's look at one set A with values as 2, 4, 6, 7 like this up to 121, total 10 values. We have to compute 10% trimmed mean. Computing 10% of trimmed mean means we will be trimming using a trim factor which will be 0.1. It means for 10 values we will be trimming one value from each end, and when we do so, what we get is we get an addition of 4, 6 like this up to 105. We skip the value 2 and 121, and we get a trimmed mean as 40.624. While computing mean, we realize that when data is not symmetric, if it is a skewed data, then better measure for computing center is median than a mean. Now in median, what we do is, in median computation, we find a middle value of a ordered set. It is the value that separates higher half of a data from a lower half. We may have n as odd or even. If n is odd, then median is the middle value of a ordered set, whereas if n is even, then median cannot be unique because at middle we have two values, and then our median may lie in between these two values. So if x is numeric attribute, then median is average of the middle two values. Let's look at one example. We have, suppose, set A with salary represented in $1,000. This data, if you look at, it is in already a increasing order. The number of observations, that is value of n, is even. Now if we want to find out median, then it is going to be the middle two values, that is 52 and 56. Our median is going to lie between 6th and 7th value, that is between these two values. So let us compute median using these. So by convention, we are going to compute a median as average of these two values. So we take 52 plus 56 and divide by 2 and we get a median salary for this given salary set as $54,000. Let us look at one more example. Here we have set A1 with values from 1530 to 17 up to 110, again a salary in thousands. Here now instead of 12 we have 11 values, and as the values are odd we are going to have a median which will be the middlemost value. Total number of numbers are 11, so we try to find a middle position as 6, and a value at 6th position is $52,000 as a salary. Let's look at one more example for computing a median. Here this example is grouped values in intervals which we had seen in the sample data sets. For the marks, we had an interval like that, marks lying between 0 to 10, then 11 to 20, and so on. So let's assume that the data are grouped in intervals according to their xi data values and its frequency in for that particular interval known. Examples are marks of students which are grouped in the range. Here the interval that contains the median frequency is a median interval. Look at this data set. We have odd number of data samples, so whichever is middle value that becomes a median. Look at this another set. Here the total number of samples are even, so middle two values are going to decide which is the median. So what we do is we take a average of these two values and that results into median. Now this third set sample is to know about if we change this data samples whether it affects the median. Except the middle value, if we change the remaining values, will it affect the value of a median? If this is the data set and this is the medial value, then 46 is our median. Now let's change few values. Those which are highlighted are the values which are changed. Even though we change these values, our median still remains same, which is a middle value in this data range. This is the difference which you can note between computation of mean and computation of median. In mean, as it was average of all the values, when value changed, mean was changed. Here, as it is, median is the middle value. Even though we change the remaining values, it is not affecting the median value. So from these examples, we could understand that median is expensive to compute when we have large number of observations. When we have large number of observations, then we need to compute a median as a middle value. For numeric attributes, however, we can easily approximate the value. Extreme values, which we call as outliers, are not affecting a value of a median as strongly as it was affecting the mean. So when we are comparing the sets of data, then median is useful, and as it is unique, there will be only one answer. We computed median as a middle value. We can approximate the median for an entire data set. Like in earlier example of a salary, we can compute approximate salary by interpolating with the help of interpolation formula. Here in this formula, L1 is lower boundary of the median interval, N is number of values for an entire set, and then summation of frequency is the sum of frequencies for all of the intervals that are lower than a median interval. We had a values listed in the intervals. Like for marks, we had something like between 0 to 10, how many students scored? Between 11 to 20, how many students scored? The same way, we can take summation of these frequencies for all intervals that are lower than median interval. And then frequency of median is the frequency of median interval, and width is nothing but width of that. Like mean and median, mode is the third popular measure of central tendency. Mode for any set of data is value that occurs most frequently. It can be determined qualitatively for both qualitative and quantitative attributes. In a set, you may find that some particular element occurs more frequently. Like we computed number of frequency for words in particular document. We realize that there are some words like maybe, good, excellent, which appeared more number of times. So it is possible for greatest frequency to correspond to several different values, which results in more than one mode. So if one particular word appeared, let's say, 10 number of times, say good, and excellent also appeared 10 number of times, then they both represent mode. So there are chances that we may have more than one mode for a given set. Data sets with 1, 2 or 3 modes are respectively called as unimodal, bimodal and trimodal. In general, a data set with 2 or more modes is called as a multimodal, and if it is single, then it is unimodal. At other extreme, if each data value occurs only once, then there is no mode. When we are computing, let's say, a frequency of some particular marks for the set of 10 students, and if we have a list of marks, if every student has scored totally different marks, no student marks are same, then there won't be a single mode for that particular set. Let's look at this example. Suppose we have following values for the salary in thousands as 30, 36, so on up to 110. We see that all the values are unique except 52 has appeared twice and 70 has appeared twice. So we say that this particular data is bimodal data, and there are two modes, one is 52,000 and other is 70,000. For unimodal numeric data that are moderately skewed, that is, it is asymmetric, we have following empirical relation which states that mean minus mode is approximately equal to 3 into mean minus median. One more terminology which we will revise is range, a simple term which indicates difference between the greatest value of a data and the least. When looking at data, we often understand the spread of data. A gap between greatest and smallest value is nothing but spread of that data. This is a range for that particular data. To find range, it is simple. We subtract the least value from the greatest value, and what we get is range. If we have a data, say 2, 5, 3, 4, 5, 5, then the lowest value here is 2 and the highest value here is 5. So we say that 5 minus 2 is 3. That is the range for this. One more term which is used as central tendency measure is mid-range. Mid-range can also be used to assess the central tendency of any numeric data set. What is mid-range? Is nothing but average of largest and smallest value in the set. To compute range, we subtracted smallest value from largest, that was range. Now we are going to take these same two terms but take an average of them, that will represent mid-range. For example of salary data, mid-range will be lowest salary 30,000 plus highest salary 110,000 divided by 2, it comes out to be 70,000 as a mid-range salary. Let's look at this figure. This represents a symmetric data. When we have all mean, median and mode lying in the same range, then we say that the data is symmetric. But it is realized in real life that most of the times data is not symmetric. Instead, it is either positively skewed or it is negatively skewed. Let's look at these two graphs. In this positively skewed data, you can see that mode, mean and median are not at the same central location. Rather, we have mode on left side and we say that it is positively skewed data. Similarly, this is said to be a negatively skewed data. This is an assignment to be done at home. You are given 12 days timings when you go by bus or by walking from home to office, and you have to find out which method for the travel is faster. You may realize that looking at mean, median and mode, that maybe bus is faster, but you have to assure that bus is always faster. So from this study, we can summarize few points that measure of center helps you to analyze the numerical data. Mean, which is also called as arithmetic mean, is often an average, and it is computed by taking sum of all items by dividing number of items. Median is nothing but a middlemost position number, and mode is the number which appears more frequently. If there is single mode, then we call it as a unimodal, else it is a multimodal data. Range is difference between the higher and lower values, and mid-range is nothing but average of lower and middle value. In next lecture, we shall learn about what is data processing, what is need of data processing, and we shall learn about 5 data pre-processing techniques, of which data cleaning and data integration we'll learn in the next lecture, and in further lecture we'll learn about data reduction, transformation and discretization. Hopefully you understood the topics which we learned today. vhp2020.mcerc@gmail.com is my email ID. Submit all the assignments given for today's lecture and post your feedback and queries at this email ID. You can visit site www.mcoerc.org for next lecture. Browsing through this site, you will also able to see the various courses for which the video lectures are offered. Thank you.